Hi, welcome to today's video. I'm going to be giving you an introduction to pH. In particular, I'm just going to be talking just a little bit around what pH is and then how we do pH calculations. So pH is a logarithmic scale. Now logarithms are just a mathematical function that we use, right? And they're a logarithmic scale to tell us the concentration of H+ ions in solution. Okay. Now the pH scale goes from 1 all the way up to 14. So we generally go 1, we go to 7, and then we go up to 14. So 7 in the middle is what we call neutral. Okay, so that's where we basically have an equal concentration of acid and base, so it's a neutral substance. Anything below 7 is acidic, and everything above 7 is basic. So it's a logarithmic scale, and it's based upon this relationship. The pH is the negative log concentration of H+. So square brackets mean concentration. Now the logarithm, this is just a function on your calculator. So if you have a look on your calculator, you should see something that says log. That stands for logarithm. That's what we're using for these calculations. Okay. Now, because it's a logarithmic scale, what that means is it's based on powers of 10. Okay. So if we've got something that has a pH of 6, and then you compare that to something that has a pH of 5, that means from here to here is 10 times more acidic. So something with a pH of 5 is 10 times more acidic than something with a pH of 6. Something with a pH of 4 is 10 times more acidic than something with a pH of 5. But it is actually 100 times more acidic than something that has a pH of 6. And you can keep going down, obviously. If you get down to a pH of equal to 3, that's 10 times more acidic than something with a pH of 4, but it is 1,000 times more acidic than something with a pH of 6. So it's all just based upon the logarithm scale. Okay, so I'm just going to show you quickly how we do some calculations involving this and using the log value here. Okay, and yeah, just bear with me while I rub this off. Okay, so I'm going to show you how we do a calculation, just a simple one first, involving pH negative log H+. Just excuse me while I have some of that Farmers Union good. All right, so the first thing I'm just going to look at is if we have an acid, like hydrochloric acid, HCl, and if we know that the concentration of the hydrochloric acid is 0.025 moles per litre or molar, how do we calculate what the pH of that solution would be? Okay, well, you just put it into your calculator, so pH, so you literally do these steps. Now, don't do the minus sign, like as if you're subtracting. On your calculator, there should actually be a negative button. So normally it's in brackets. So what I mean by that, so it kind of looks like this. It's got a negative sign in brackets like that. That's the one you'll use. So you press negative, then you press your log button. So there should be a button that says log on it. Put that in. And then just put in your value. Now, I'm putting brackets in here to show that I'm putting the value in, but you don't need to do it on your calculator. You can just press negative, log, and you put in the concentration we've got up here, 0.025, all right? And that gives us a pH of 1.6. Now, pH does not have units, okay, because we're doing a logarithm of the concentration, no units. So the pH of a 0.025 molar HCl solution would be 1.6. Now, the one trick you've got to remember, so that's fairly straightforward, hopefully, but there is one little trick that you have to remember. If you have a diprotic or triprotic acid, so a diprotic acid is something with 2 protons in the formula, a triprotic acid is something with 3 protons in the formula. So an example of a diprotic acid would be sulfuric acid, H2SO4. And if we've got some sulfuric acid that has a concentration of 0.05 molar, okay, we need to work out, sorry, I just need to change that concentration a little bit. Three, two, one. So if we've got sulfuric acid, which is an example of a diprotic acid because it's got 2 protons in there, and that has a concentration of 0.005 molar, how do we work out the concentration? The pH. Well, the thing you've got to remember is that we need concentration of H+. This is the concentration of the sulfuric acid. If we're looking at the hydrogen in here, every sulfuric acid molecule actually has 2 hydrogens in here. So the actual concentration of the hydrogen ion is actually 0.005 times 2, because there's 2 hydrogens within each sulfuric acid molecule. Okay, so the concentration of H plus that we're going to use is actually 0.01. Okay, and that's the trick that some people forget. If it's a triprotic acid like H3PO4, you would have to multiply the concentration of the acid by 3. But then the next step's exactly the same. pH equals negative log concentration of H plus, which is 0.01. So if you put that into your calculator, you get a pH of 2. Okay, so as long as you remember for a diprotic or triprotic acid to multiply the concentration of the acid by the number of H plus that you've got, you'll still be able to get the same answer. But what about if we want to go in reverse? What if we know the pH and we want to calculate what the concentration of H plus is that we've got? Well, I'm going to show you that now. So let's say, for example, that we had nitric acid this time. Okay, just a monoprotic acid, it's only got the 1 H in there. And we know that the pH of this nitric acid that we've got is 2.2. So the pH is equal to 2.2. Okay. Well, then we just use this yellow equation this time, where the concentration of H plus is 10 to the negative pH. So again, this is really straightforward to do on your calculator. So the concentration of your H plus, you put in, now normally, there's 2 ways you can do this on your calculator. You can type in 10, and then there's normally a little up arrow that looks like that. You can do to the power of, and then you can put in the negative button, which is, so if I was doing this on a calculator, I would write 1, 0, up arrow, I'd put the negative in the brackets, and then I would put 2.2 in there, okay? Sometimes your calculator will actually have a, like a 10 to the power of button as well. You just need to play with your calculator because there's so many different brands, I can't go through them all here, sorry. Just find out which one you can do 10 to the power of button. But if you do all of that, if you do 10 to the negative 2.2, you end up with a value of 0.0063 molar. We must have the units in here. Another way of writing that for scientific notation would be 6.3 by 10 to the negative 3 moles per litre or molar. I'm just putting both units in there. Okay, you need to be able to do scientific notation, particularly with pH calculations, because quite often we deal with very small numbers. Okay, but it's a very, very straightforward calculation to do, providing you practice it with your calculator. Okay, now, unlike the one before, you don't need to worry about if it's a diprotic or triprotic acid, because you're automatically calculating H plus concentration. So all you've got to do is do 10 to the negative pH. Okay. Now, the last thing I'm going to show, just one example, is how can you calculate the pH or the concentration of H plus if you've got a base? Well, you can actually do it. So I'm just going to show you quickly how you do that now. So if you've got a base, and I'm just going to use sodium hydroxide as an example here, NaOH. If that has a concentration equal to 0.01 molar, okay, how can we calculate the pH from that? Because pH is reliant upon the concentration of H plus, okay? Well, what we do is we use this final blue equation down the bottom here, okay? So if we know that the concentration of OH hydroxide ions, OH minus, is 0.01, we use this equation. We just rearrange it a little bit because we're trying to get H plus, so we're dividing both sides by OH minus. So the concentration of H plus is going to be 10 to the negative 14, and remember the pH scale is a range of 14, that's why it's 10 to the negative 14, divided by concentration of hydroxide ions, OH minus. Okay, so that's going to be 10 to the negative 14 divided by 0.01. Okay, now you can work that out if you want, but it doesn't even matter, we don't need to, because we can just plug that straight in here to our pH calculation. So pH is negative log, and then we put these values in, 10 to the negative 14 over 0.01. Put all that in, and you're going to end up with a pH of 12, which is what you kind of expect because we're talking about a solution of sodium hydroxide. So you expect it to have a high pH because it's basic. All right, so this has been a short introduction to pH. And the pH scale, remember it's a logarithmic scale to tell us the concentration of H plus ions in solution. There's three main equations that we want to look at: how pH is negative log concentration of H plus, concentration of H plus ions is 10 to the negative pH, and if you use concentration of H plus times concentration of OH minus, that equals 10 to the minus 14. You can use it if you have a base as well. All right, hopefully this has been straightforward for you. If you've got any questions, just ask. If you're struggling with it a little bit, just remember this one good piece of advice. Everything goes better with a Farmer's Union iced coffee. All right, have a good one, guys. Stay safe. Thanks.